With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, the question is H2O2 gives H2O plus O2. That means hydrogen peroxide gives H2O plus O2. The rate constant for this reaction is 2 into 10 raised to minus 2 per minute. Okay, at certain temperature. And reaction is started with 0.5 molar concentration of H2O2. After 23.03 minutes, the reaction was suddenly stopped by lowering the temperature, and the remaining H2O2 was completely reacted with NaOCl. That means sodium hypochlorite. If number of moles of O2 produced in second reaction is 1 by A, find the value of A. Given that log 1.5 is equal to 0.2. Okay, let us see the solution. Here two reactions are happening. First reaction is first chemical reaction is H2O2, that is hydrogen peroxide, gives H2O plus O2. Okay, first let us balance this chemical reaction. Here two hydrogen, here two hydrogen, here two oxygen, but here 3 oxygen. To balance that, let us put a 2 here. Then here we will get 2. Then 4 hydrogen, 4 hydrogen. Then 4 oxygen. Here also 4 oxygen. So the first chemical reaction is balanced. And given that rate constant of this reaction is 2 into 10 raised to minus 2 per minute. Rate constant of first reaction is equal to 2 into 10 raised to minus 2 per minute. Okay, and the reaction is started with 0.5 molar concentration of H2O2. Hence initial concentration of H2O2 is equal to 0.5 moles. Now what's happening after 23.03 minutes? Okay, so time for the first chemical reaction. Time T for the first chemical reaction is equal to 23.03 minute. The reaction was suddenly stopped. Okay, the reaction is suddenly stopped. Hence, we can write the equation for rate constant of the first reaction. From the unit of rate constant, we can understand that this is a first order reaction. Okay, so hence first chemical reaction is first order. From this unit of rate constant, this reaction is first order chemical reaction. This reaction is first order reaction. Hence, we can write the equation to find the rate constant. The equation to find the rate constant is rate constant K is equal to 2.303 divided by T into log to the base 10 into A divided by A minus X. Okay, where A is the initial concentration. A is the initial concentration and A minus X is the final concentration. Okay, or number of moles remaining. Okay, so we have K, T and A. We can find A minus X from this equation. That is final concentration of H2O2 or number of moles of H2O2 remaining in the first chemical reaction. Okay, so let us write that. K is given that 2 into 10 raised to minus 2 minute inverse is equal to 2.303 divided by 23.03 minute. This minute inverse and this minute inverse will get cancelled. Log to the base 10. A is given as initial concentration of H2O2. That is 0.5 moles divided by A minus X. Okay, and find the value of A minus X from by solving this equation. Okay, so 2 into 10 raised to minus 2 will become 0.02 is equal to, here when we multiply and divide by 10, 23.03 into 10 log to the base 10, 0.5 divided by A minus X. This is equal to 0.02 is equal to, here 23.03 divided by 23.03 into 10 into log to the base 10, 0.5 divided by A minus X. Here 23.03 and 23.03 we will get cancelled and we will get 1 by 10. This 10 we can multiply here. So 0.02 into 10 is equal to log to the base 10, 0.5 divided by A minus X. That is equal to 0.2 is equal to log to the base 10, 0.5 divided by A minus X. Okay, now 0.2 is given as 0.2 is equal to log 1.5. Okay, so we can substitute for 0.2 as log 1.5 is equal to log 0.5 divided by A minus X. So both sides there is logarithmic function, it will get cancelled. So we will get 1.5 is equal to 0.5 divided by A minus X. So this is equal to 0.5 if we take to the left hand side, 1.5 divided by 0.5 is equal to 1 divided by A minus X. That is 3 is equal to 1 divided by A minus X. Okay, so A minus X is equal to A minus X is equal to 3. What is A minus X? A minus X is the final concentration of hydrogen peroxide. A minus X is final concentration of H2O2 after first chemical reaction. After first chemical reaction. That is number of moles of H2O2 remaining after first chemical reaction. Okay. Now let us write the equation for second chemical reaction. The second chemical reaction says that the remaining H2O2 was completely reacted with NaOCl. So let us write the equation for that. So here H2O2 is reacting with sodium hypochlorite, which will give one H2O plus NaCl plus O2. Let us balance the equation. Here 2 hydrogen, here also 2 hydrogen, here 3 oxygen, here 3 oxygen, 1 sodium, 1 chlorine. Okay, the equation is balanced. Okay, so 1 mole of H2O2 reacting with NaOC, 1 mole of NaOCl gives 1 mole of H2O plus 1 mole of NaCl plus 1 mole of oxygen. Okay, that means 1 mole of H2O2 reacting with 1 mole of NaOCl gives 1 mole of H2O, 1 mole of NaCl and 1 mole of O2. Okay, so during the second reaction, the number of moles of oxygen produced will be equal to number of moles of H2O2 reacted. Okay, do you understand? That is, during second chemical reaction, number of moles of O2 produced will be equal to number of moles of O2 produced will be equal to number of moles of H2O2 reacted, because the ratio is 1:1 here. Okay, so the question asked is, we have to find the number of moles of oxygen produced. Number of moles of oxygen produced in second reaction is 1 by A, then find A. Okay. Here number of moles of H2O2 reacted will be equal to number of moles of H2O2 left after first reaction. Okay, that is A minus X. That is equal to 3. Okay, now number of moles of oxygen produced is 1 by A. A minus X is 1 by 3. Okay, sorry. Number of moles of O2 produced is equal to 1 by A. If this is equal to 1 by 3, then A is equal to 3 is the answer. Okay. So our answer is A is equal to 3. Hope you understand the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.